So there's the definition. So how does this work? Say I have the function f of x equals 5x plus 2. And I want to determine, so I want to use the definition to determine if f of x is 1 to 1. 1 to 1. So I'm going to use the definition. I'm going to do this algebraically. So in order to use the definition, I'm going to start with the f of a equals f of b. So f of a equals f of b. And think about what this means. We talked about function notation. What does f of a mean? What am I doing? Plugging in a, right? So on the left side, I'm plugging in a to my function. So I have 5a plus 2 equals, and on the right side, I'm plugging in b. So I would have 5b plus 2. In order for this to be a one-to-one function, I should be able to use algebra to simplify it and get a equals b. If it's one-to-one, I'll be able to simplify it and end up with just a equals b. If it's not one-to-one, then I'm going to end up with something funky, and we'll look at an example of that in just a second. But so I'm going to do some algebra. I'm going to try and get a by itself and b by itself. So I can subtract 2 from both sides, and I get 5a equals 5b. And then I can divide both sides by 5, and I end up a equals b, which is what I need to show that this is a one-to-one function. Okay? All right, so let's look at one more example. So I have the function f of x equals 3x squared minus 7. And same task, I want to use the definition of a one-to-one function to determine if f of x is in fact one-to-one. So I'm going to, again, start with the beginning portion of the definition, f of a equals f of b. And I'm going to write in what those two things mean. F of a means I'm plugging in a for x. So I would have 3a squared minus 7 equals. And on the right side, I have f of b, which means I'm plugging b in for x. So I have 3b squared minus 7. And now I'm going to use my algebra skills to see if I can isolate a and b. So what could my first step be? Add 7 to both sides, right? Just simplifying. And I get 3a squared equals 3b squared. Now divide both sides by 3. I get a squared equals b squared. I need to see if I can get just plain a, just plain b. I have a squared and b squared. What can I do? Take the square root. What happens when I take the square root? What do I have to account for? The plus or minus, right? So I have plus or minus a equals plus or minus b. What does that mean? It's not one-to-one, right? If I break this down, I have a whole bunch of different options I could have here. I could have positive a and positive b, or I could have negative a and positive b, or I could have positive a and negative b, or they both could be negative, right? So I have 4 different options here. So possibly a could be the opposite of b, but it's still giving me the same y value, right? I don't have just a and just b. When this happens, then my function is not one-to-one. Okay, if you cannot isolate just a and just b, then you know your function is not one-to-one. Okay? Questions about that? So we took the square root, and I got plus or minus, right? Because it was a squared. What if it was a to the third power? Would I still have to account for the plus or minus? No. When do I have to account for the plus or minus? Only when what? Only when the power is even. If it was to the third power, or the fifth power, or the seventh power, or anything like that, I don't have to worry about the plus or minus. Okay? So only when my power is even do I have to account for the plus or minus. All right. Okay, so we've determined if I have a one-to-one function. Now let's look at what that actually means. So if a function is one-to-one, that means when I take its inverse, the thing that I get back out is actually a function as well. So let's look at actually finding inverses of functions. And we'll talk a lot later about what inverses of functions mean. Right now, let's just worry about the algebra actually finding the inverse. What does an inverse function do? Anybody remember from Algebra 2? That's definitely one way to algebraically find my inverse, right? It switches the x and y values. So if I have two functions that are inverses of each other, their domain and range will be swapped, right? If I have two functions that are inverses, those functions will undo each other. Okay, so simple example. Say I have f of x equals x plus 2. That means when I plug in a number, I'm going to add 2 to it. Right? How would I undo that? I added 2 to a number. How do I get back to that original number? Just subtract 2, right? So the inverse of f, the notation we use is f with a little -1. That means f inverse of x. The inverse is going to undo what the other function did. So this function added 2, so the inverse will just subtract 2. Of course, it gets a little more complicated than that, but if you just keep this in mind the whole time, then it makes it quite simple. So let's look at another example. Let's say g of x is equal to 4x plus 6, and I want to find g inverse of x. Find g inverse of x. So one way to go about this is to look at what g of x is telling me to do. And I'm going to make a little list. All right, so when I plug in a value for x, what is the first thing g of x tells me to do? What does it say to do? Think of your order of operations. What does it say? Multiply by 4, right? So I'm going to make a list. The first thing I would do is multiply by 4. And then what? After I multiply that value by 4, what do I do? Add 6. So plus 6. Well, the inverse is going to do the complete opposite in the reverse order. So to find my inverse, after I've made my little list, start from the bottom of your list, work backwards, and do the opposite as you go. So g inverse of x, I'm going to start with x, and then I'm going to start at the bottom of my list and do the opposite of what it said. The last thing g of x does is add 6. So the first thing g inverse will do is subtract 6. Moving up my list, so I did that. Moving up my list, then it says to multiply by 4. I'm going to do the opposite. What's the opposite of multiplying by 4? Divide. So I'm going to divide the whole thing by 4. And there's my inverse. Just like that. Okay. All right, one more. Let's get a little crazier. So I have f of x equals 3 times the square root of x minus 2 plus 7. And I want to find f inverse of x. So I'm going to start off the same exact way. I'm going to make a list of what f does to my x value. So I'm going to go in, I'm going to look, okay, here's x. Think of your order of operations. What would be the first thing that I would have to do if I plugged in a value for x? Subtract 2, so subtract 2, and then what? Take the square root, right? I'm starting on the inside, just working my way out. I would subtract 2, and then whatever I got under there, I would have to take the square root. Boop. And then once I took the square root, what would I have to do? Multiply by 3, right? This 3 on the outside, so I'm going to multiply by 3. And then what's the last thing? Add my 7. So to find the inverse, I'm going to start at the bottom, work my way up, and do the opposite as I go. So f inverse, it's going to take x, and starting at the bottom of my list, I'm going to do the opposite. Instead of adding 7, I'll subtract 7. Boop, it's gone. And then I'll move up. Instead of multiplying by 3, I'm going to divide all that by 3. So I'm just adding on to whatever I have as I go. Divide by 3. The next thing it says is to take the square root. What's the opposite of the square root? How would I undo it? Square it. So I'm going to take that whole thing, right, because I'm building as I go, and I'm going to square that value. And now it's gone. And so now I'm at the top of my list. It said to subtract 2, so I'm going to add 2. And there's my inverse. Okay. Questions about finding inverses?